Okay. So therefore, once we know theta, we can draw this diagram, and this becomes the development of this. Clear? Development of this. Okay, clear? Is it clear? Sure. 100%? 200%? How much? Any doubt? Means is the first of all is the philosophy, is the concept clear? Clear? So basically we have to produce a 3D object. For that we start with a 2D object. But how to design the 2D so that when we wrap it, it becomes the exact set. Right? But here what we have done is, for example, this box. There are some extra parts like this, isn't it? Extra part. Or then you will see that there are some extra part where it is pasted, right? Overlap. So that extra part you have to do. That means here, say for example, there will be some extra part that is simply for pasting, right? But the exact shape of the object is like this. Or here there will be some extra part, right? So say for example here, like this. So on the top you have extra part. So it will be joined with this one, and this will be simply for covering it. And there are two sides, right? But this is only for packaging. But for this dimension, only 6 faces are okay. 6 faces are alright. Is it clear? So these are only for making the completion. But according to the geometry, only 6 faces are enough. 1, 2, 3, 4, 5, 6. Right? So here, which one is the top surface? Can you tell? This is the top surface. Top one. Then this is this one. Sorry. This is top one. Then this is the side. So this is the front. Say front. Right? And this is the bottom. This one is the bottom. And this is the back. Then this is what? The left side. And this is the right side. It's like this. Yeah, isn't it? So is it clear? So this is the development of this surface. So we have this. The final shape is this. We start with this sheet. Then we mark this and then get this length, get this angle from the perimeter of this circle, therefore pi d, and we know this length, therefore the angle in radian, because this formula is for that, that means two lengths are having the same unit as that of length, and this is radian. So pi d by L. Okay. So you know d, you know L, therefore you can determine this. And therefore, once you know this, you can measure this. From angular measurement, you can do this. Length measurement, according to the straight line measurement, you can do, but curved line measurement you don't know. So you do it via angle measurement. Clear or not? Okay. So this is one example. These are 3 examples like that. Okay. Now let us write the problems. Clear? A cylinder of 40 mm diameter, 60 mm height, and having its axis vertical, just like this.
height
60 mm height and having its axis vertical. The cylinder having its axis vertical, like this. Is cut by a section plane. Is cut by a section plane. That means this cylinder was there, it cut by a section plane. Okay. So this is another level of this problem. Clear? Another level, means next level of this problem. So not only we can solve simple diagrams, even if you have some plane which is basically cutting this, for example like this. It is cutting here somewhere, right? We may mark the cutting lines while it is intersecting. Say for example it is intersecting here. So we may ask you to draw the development for the lower part. That means as if the upper part is not there, simply draw the lower part. So in that case, you see what will be the diagram? This length, this length, this length, all these lengths are known, isn't it? If I can project from the projection, means by this time you know how to draw the section plane and how to measure the lengths from different projections, right? So if I know these lengths, for example, I have a complete length. Follow. I have this complete length. So this is the complete length, or this is the complete length. So I have two lengths. One is up to this point, another is up to this point. Right? Therefore, what I will do, I will divide this circle into equal number of divisions. Maybe equal, maybe not equal. There is no limit for that, or there is no such condition criteria. But simply we will go for dividing it into equal number of divisions. Now, for example, 12 divisions or 16 divisions, whatever. Now, what we do basically, I mark them. Say for example 1. Then say for example let me divide it. So 4. Then we have say these will be all construction lines. Okay. Next, you see for all such lines, it started here and ended on the periphery. So one by one we will track. So we start here, and then for this, for example, I have 12 lines, right? Here there will be total 13 lines. What are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. But this line and this line they are same because they will be joined. So basically this line and this line their numbering will be same. So for example, let me number them as say 1, then 2, then 3, then 4, 5, 6, 7, 8, 9, 10, 11, 12 and 1. It goes back to 1. Right? Now, say this is say 1. Then this is say 2. This is 3. This is 4, 5, 6, 7 like this. Okay. Next part 1, 2, 3, 1, 2, 3, 4, 5, 6, right? 7. Then again on the back side there are equal number of divisions. So what we do basically, we measure two lengths. One is up to this, which is already there. Another is up to this. I can measure this, right? From the diagrams from the front view, I can measure. So simply measure that and put it here. So it is here. Next, what? This length. This length on the next line, 2, line 2. So this much. So this length 2, say this much. Next 3, it is little more. 3. Next 4, it is further more. 4, where? Sorry, 3 is here. This is 3 here. 4 is here. 4 is here. Next, then 3, then 4, then 5. 5 is here, little more than that. So 5 is here. Next, 6 is here. Still more, and then 7 maximum. And again it is going back. So 7 is maximum. 7 is maximum, and then same as the 8 is same as 6 is here. Then 5 and 9 are same, so I can just join them just by small. Then next one, this one, next one, from here 3 and 11. 3 and 11, and then what? 2 and 12, 2 and 12, and 1 and 1 they are same. So it is here. Right? Now what we do? Basically we just join by a card. So it is like this. It's like this. And this part will be faint lines, and the outline I can draw like this. Okay, and this part will be faint lines, construction lines. Clear? Therefore, this is the surface from which you can produce this. Which one? Only this part, the lower part. So you have basically the lower part of the conical surface. Okay, and this is actually not there, so it is with the faint lines. Definitely they will be all faint lines. They will be all faint lines. Yeah, is it clear? So actually you have to produce this truncated cone. So how to produce a truncated cone? Is it clear? Is it clear? So that is a difficult one. That is a difficult one. But if I ask you to do similar thing for a cylinder, similar thing, the cutting plane is like this. Okay, one thing. Another thing is, say for example, if I ask you, say for example, same cone, similar cone,